Just looking at this issue of close coupled T's on underfloor heating manifolds and the effect of forming a bypass. And it's occurred to me that actually I need to restate my position slightly on this and actually make a fuller statement. So rather than saying no close coupled T's before an underfloor heating manifold, I should clear this up and say no close coupled T's on an underfloor heating manifold when the underfloor heating manifold is piped in parallel to a radiator. And for those of you that know about the A-plan, which is my version of the Worcester Bosch design, which uses primary-secondary configuration for the underfloor, this is when you use close coupled T's off of the primary flow in the Worcester's case, or primary return in the case of the A-plan. Then we have got close coupled T's before an underfloor heating manifold in that design, in effect. So can't really say no close coupled T's before an underfloor heating manifold and then tell you to do that design. But what we can say is no close coupled T's before an underfloor heating manifold when it is connected in parallel. Now, the reason that I'm trying to get across for this is that if we look at a balanced system and we connect any system with a form of bypass or short circuit, as I call it, across a parallel intersection in parallel to radiators, we will get a short circuit here, a flow of water crossing through our system. And at any point that happens, we will experience an underflow to our radiator circuit. That underflow will widen the delta Cree across that circuit and reduce the mean water temperature at this radiator. Now, if we get that, we're going to reduce the heat output. So in the balanced circuit here, we've got a flow of 7.14 and we've got a radiator running at delta T20, giving us a 10 kilowatt load. And in the second picture, I'm assuming the same flow rate here, same flow temperature, and we're saying 50% is going to go through this bypass. That's just for the sake of the argument. And 50% is still going off around this radiator. And so we're ending up with this wider delta T. And the temperature coming back to the boiler, this will no longer be delta T20 across here. It will be higher. We will have a raised return temperature. And I know that's pretentious as well, or contentious rather. But the return temperature will be higher with this bypass. We will have a raised return temperature. Now that boiler is still targeting 50 degrees, so the boiler will modulate down. We'll have a lower delta T, a raised return temperature, and the boiler will output the matching requirement for this radiator. So I hope that helps. I don't think we really need to draw in the underfloor heating circuit in here to demonstrate it any further. But so to clarify the rule, basically no close coupled T's before a manifold when in parallel to a radiator circuit. Just one more thing, if you were to put a balancing valve in to the underfloor heating circuit, which still allowed a bypass rate, all you're doing is reducing the severity of the bypass or the short circuit, and therefore you're reducing the impact of under output from the radiator circuit. Easy to get over, don't do it. Basically just run from primary secondary layout, so put your close coupled T in on this circuit and run off to your underfloor heating, so your flow and returns will both connect into either the flow or the return of any one circuit. I think that's okay. Any questions? I may have missed something. I may not have been too clear. So if you want to fire up some questions, I'll try and answer them. And I hope that helps.